Hello there, it's Daddy and Bean make a thing.
Hello.
There's Bean. And we're going to talk to the electronics of the EEZYBot or the EEZYBotARM by the Gizmo. Right, so you've got the robot arm, and the robot arm is powered by a bunch of things. So if you have your robot arm, and we'll just sort of draw as best we can, a little robot arm, a couple of degrees of freedom. You've got your rotation. You've got your 3 stepper motors, so 1, 2, 3, and you've got your top bit, which is controlled by just a cross arm, so it always stays roughly level, and a servo sitting up there. So we know, that we've got 3 things that need powering. We have motor 1, we have motor 2, and we have motor 3. And we have servos. So we have a servo, which is the thing that closes little pincers. So I need to still make the spring for. We'll call that S1. Okay? And then each of these can't be powered. Oh, we're going to need that bit. It's a good smiley face. Each motor and the servo, but definitely each motor, needs to be powered from something that isn't the microcontroller. So we have the microcontroller here, and it is a Raspberry Pi Pico using MicroPython, and it can't put out much in the way of ampage. Each of these little pins can only put out a little bit.
Can I draw a Raspberry Pi Pico thing?
In a minute.
Just a boxing Raspberry.
Just there. Excellent. So we have the microcontroller, and we're going to put that here. So could you do me a big box there? That's good. So this is our microcontroller. And it's a Pico. This has 3.3 volts that it operates on, but our motors run at 5 volts. And our servo runs at 5 volts. So we need to mess around with that. You can put 5 volts into this. So you can power it with 5 volts, which is okay, so we'll kind of work with that. Now, each of these motors, if we powered it directly from the microcontroller, would blow the microcontroller. So we need a thing between it. And the thing between it is a little chip called a URN 2003.
Cool.
And we need 3 of those. And luckily, those come on pre-organized boards that work with the Raspberry Pi. So you put your power into those sockets where you put your GPO pins into those pins, and then they'll put the power out in a way that can be controlled by the motor. And you have the power going in there. Yes, you control it. Yeah, good place for it.
What's it called again?
It's a URN 2003, which is just a bunch of transistors, really. And it insulates the power that the motor is drawing from the power that's being used to power the logic. And that way you can draw a lot more current. If you're using really big things, like in or even a little bit bigger things, like in your 3D printer, it also uses stuff like this, but has a much bigger power control than this little thing here. It's got proper transistors. Okay, so we've got our microcontroller. Now we need to tell our microcontroller whether or not it should be powering these forward or backwards, or shutting this or opening it. So to do that, I've made a little set of buttons. So you got left, right, up, down, in, out, and close and open. So you've got 2 buttons for each thing, and there are 4 things. So you've got a board with 4 buttons. Can you draw me a board with 4 buttons?
4 buttons?
8 buttons, sorry. That's it. And you can see the board I put together here just on a piece of perf board, which is stuck together so that each of these buttons, when they're pressed, they put one of these pins high. Now I'll plug all this together, but I'll have to debug it because I made all the wires. So I'm not 100% certain they're fully connected.
Did you bring realised it's upside down.
Ah, we're going to sort that out post-processing. So, we now need power as well. So this thing needs to be powered by something. And I've made a little power board.
Can I do the power board?
So the power board, if you put the power board there. It's good enough.
P. B.
So the power board has a bunch of wires coming out of it, each that are providing positive and negative, a way for me to attach a cord. I've actually got a USB I've modified, which will plug into those. And I've also put on a 680 UF capacitor so that I can smooth out some of the current flow in the circuits. Servos tend to draw a lot of current when they're trying to do stuff, and they get a bit jittery when it goes weird, and so can the motors, I think.
Question.
So I've just thrown that in there to clean it all up.
Question.
Mhm.
If there's 3 buttons and the 3 buttons have 2 buttons.
4 buttons.
If there's
Those are the
3
motors.
motors.
Yep.
And the 3 motors have 2 buttons each. Why are there 8 buttons?
Because you've also got a servo to close the pinchers.
Dum, dum, dum,
You got to close them and you got to open them. Right, so we've got to connect this up. So we've got to connect up that, with that, with that, and those go in there. Luckily, that's all organized through that little socket there. So this bit's dealt with. And we've got to connect our microcontroller to our board, and we've got to get power. Okay. And we've got to get power from the power section down to the servo, to each motor, and to the microcontroller. That make sense?
Yeah.
Okay, so let's do a quick schematic of what that's going to look like. I'll move this out of the way. Put it here. And oh, we don't need that any prettier. I'm going to quickly tidy it up so I don't get the table dirty. Ready?
Why are you rubbing it out?
Because I get the table dirty otherwise.
How do you get the table dirty?
I got the board dirty. That didn't work very well, did it? I think I need to use a bit of...
Human flesh.
Okay, so on this side, we're going to put most of this onto something called a breadboard. And a breadboard's kind of neat because what it does is it takes...
Can I draw a breadboard?
This is the breadboard. So if you could draw, because this needs to be pretty specific, if you could put a black line all the way along there. You see that line there? That's it. That is our negative rail. And here, this one.
Is our...
No, this one's a negative rail as well, just along there. That's our negative rail. Keep going down. And then we have a positive rail, and I don't have a red pen, so I'll have to use orange. And the positive rail goes from there and there. Somehow I got these the wrong way around. Never mind. We'll make it all work. No, that's fine. Let's put it that way up. So you can see this bit here. So a piece of, or breadboard works really well. You've got your ground rail, your positive rail, and then each of these lines is connected up. So we can put our board in. So if we just take this, and let's say this is our Raspberry Pi Pico. Little connector.
Where's the other one?
Which other one?
The block one. That one.
Oh, these are off the board, so these aren't pictured. I just need to show what's going to happen on this. Right, you draw on the Raspberry. Excellent. So, on this, we have kind of neat setup. So we've got some GPO pins here, here, and then we've got a block of 4 GPO pins here, 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 and here. We got another block of 4 here, and another block of 4 here. And we need 4 pins to run our stepper motors. So we've got 3 there. So this can be M1, this can be M2, this can be M3. And then our board, our button board, has 8 buttons on it. So we know that we have to power 8 buttons. So there are another 2 GPO pins there, and another 2 there, and then there's another quad of GPO pins here. So this is going to be button connector 1, and then these two, what I'm going to do is just pull a little bit of cable from here up to here, and from here up to here, so that we can call this a quad as well. Hold on a sec, Josie. Let me just put that there. And so this is button connector 2.
Where's button connector 3?
We don't need a button connector 3 because we're all right. But we do need to run the servo. So the servo needs a power line, it needs a ground, and it needs a signal. So if we take the ground, so the ground for the servo is I think on the left, and that's going to go all the way down to the ground wire. And also we need to tie our grounds together. So all the way up, and we want to tie those grounds together. So all the way across to this ground here, just so that that's all tidied up. Now, because this is operating on a 5-volt power supply, but it's a 3.3 volt board, you can put, can I use that for a moment? 5 volts into this socket here, which is your VSys, I think. And that can be 5 volts. And then we've got a 3.3 volt on the 5th pin over. And so we're going to run this as our 3.3 rail up at the top. And this is going to be our 5 volt rail. And so we need to get power from 5 volts over to the 5 volt piece. So we'll sneak that up and pop it in there. And we need power from our 3.3 up to our 3.3 rail. And then we need to power our servo. So there are going to be 3 things there. So we're going to have some power coming in there. And then we need a signal to the servo. And I'm going to take that from GPO 0, which is this one over here. So that gives us that. And I'll probably also put a capacitor between these two, just to add a little bit more resilience up at the servo. I won't bother with the motors and just see how I get on. Right, so that covers our servo, it covers our rails, it covers our buttons. We need a 3.3 up to there for the buttons, so the buttons are going to take 1 bit out of the 3.3 and we're going to run that up to the button board. And then we're going to pull these 2 cables down. And I believe that is it. So that is our board. So we can make that now.
Where are the buttons?
Here.
Yeah, but where are the buttons drawn?
Button level 1 and button level 2. I'll show you. This is the clever bit. Button connector. So that's a button connector. Well, I mean, that's what I'm calling it.
Yeah, but where's the thing? Okay.
I'll show you. So this is the perf board.
Where's the little square for it?
Oh, we don't need it because this is written small. So what you need to do is plug this in there. And you push that down carefully and sort of evenly.
That was satisfying. Is it painful?
I'm just sticking stuff in my fingers. Okay. So we've got that attached there. Now we need some wires, and I've got some pre-cut wires.
This was a bit incorrect.
Is it?
Yeah, because that needs to be way bigger.
Yeah, you're right. Well, that's the best I can do. So we know that we have a few things we need to attach. I've got some little bits of wire cut out here to make life easier. Now we know we need the servo 3, so we'll just pop them in up here. Just to get it out of the way. And we need these 2 bottom ones pulled up to over here. So we'll take that as one of them. It goes in there. And then we have another one, which is that fella. Actually, I want that one should go in.
It goes from -18 to 22.
Good reading.
goes from -17 to 720.
It's a bit big. And not 18, should be 19. Did it wrong. And this one should be 20. Okay. And then we need some grounds, just to attach our common ground. Third one along is ground. If you could push that in. 1, 2, 3. Can you push that in, Josie? There we go. And we're going to put a ground up here, just because you can't have too many grounds. Which one's a good ground? I think it is the third. Just checking my references. Third down. Yep. Could you pop that in there for me, kid? Okay, so we've got a couple of grounds in. And then we need a ground for the... We're going to join the two up. Remember we drew this big line at the back? So that one to that one. Pop that in. So you can use different power sources as long as they've got a common ground. And then this is going to be our GPRO1 to signal. And signal is the, you might do this the other way around because of the size of the thing I've cut for this. And so the signal's in the middle. Sorry, signal's on the other side than I drew on the diagram. Okay, and then we need some power to our servo. Power line on a servo is middle. 5 volts. And then we need our power from the 5 volts to the power in, so that this will have some power when it's not in, not when it's not in use, but when it's there. A little bit short. Quickly just use a cheat. I was going to use that, but I'll just use that real quick. Let's see what I'm doing. It's very stiff. And that goes to there. Right, so that gives us our 5 volts. And then we can plug in these. Oh, wait a minute. These first. So we've got these 3 motor connectors. So we know it goes in after that third. So that's 1 quad there. One quad there. And 1 quad there. So those are going to go to our ULN 2003s. And then we have our 2 button ones, which are going to go to here. So we got our 4 and our 4. And then this goes to the live from the board, and I need to take the board's 3.3 volts, which is the 5th along, and attach that to this. Right, so all of that should now work, whereas if I press these buttons, it will send the signals as long as my code is right. So that is that. What do you reckon, Josie?
Amazing.
Super cool.
I made Among Us.
Oh, just there. Good job.
Among Us. I'm gonna make a video version of him.